Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be graphing and writing radical functions. The two radical functions we'll be working with are the square root function and the cube root function. Now, in our previous two lessons, we learned about these individually, but let's just review a couple things about them. So, square root function. The most basic square root function is f of x is equal to the square root x. Square root functions have one endpoint and extend indefinitely in one direction. So what I want to review with you that the square root parent function starts at 0, 0, and then it has an ordered pair at 1, 1 and 4, 2. So we will be using these as our critical points. Let me just write them down to graph transformations of this function. Now, the most basic cube root function is f of x equals the cube root of x. Cube root functions have one turning point and extend indefinitely in opposite directions. So here's our turning point at 0, 0. We also have a point at 1, 1. And we have another critical point at 8, 2. Now we also have -1, -1, and -8, -2. All right. So in example 1, it says use the critical points from the appropriate parent function to sketch each of the following. So in problem A, we have f of x equals the square root of x minus 3. So we will be using the critical points from that square root function to graph the square root of x minus 3. So our endpoint here, because this is a square root parent function that's been shifted to the right 3, our new endpoint will be 3, 0. So 1, 2, 3, 0. Now this becomes like your new 0, 0. So if this is my new 0, 0, then I would also have a point at 1, 1. So go over 1, up 1. And a point at 4, 2. So 1, 2, 3, 4, 1, 2. So here we have the square root of x minus 3, which is just the parent function where each point has been shifted to the right 3 units. So our domain would be 3 to infinity, and our range would be 0 to infinity. All right. In problem B, we have the cube root of x plus 2 minus 3. So we're going to use the positive critical points from the cube root function, which are 0, 0, 1, 1, and 8, 2. Now let's talk about our turning point in this function. So we have cube root of x plus 2. So that means my x value of my turning point will be -2, and then we have minus 3, so minus 3. So let's plot that point, -2, -3. So this is your new 0, 0. From this 0, 0, you're going to plot 1, 1, so over 1, up 1, and then 8, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. So the positive branch of your cube root function is going to go off like that. And then I'm just going to sketch my negative part. I can go down 1 over 1. I'm not going to be able to go 1, 2, 3, 4, 5, 6, 7, 8. Oh, I can. I do have enough room to go left 8 and down 2 from there. So there's our cube root function. So remember, on the cube root, you're going to have one of your branches going off to the right and one going off to the left. So our domain is going to be -infinity to +infinity. And same thing with the range. We do not have a restricted domain because we can plug negative numbers into our cube root function. Okay. All right, problem C. we have f of x equals 2 times the square root of x plus 1 plus 2. So this is a square root function, so our ordered pairs were 0, 0, 1, 1, and 4, 2. All right, so our endpoint here, we have the square root of x plus 1, so I need to take the opposite, that'd be negative 1, and then we're moving up 2, so positive 2. So on my graph, I'm going to plot that point, left 1, up 2. This is our new 0, 0. But now I want you to notice that this function has been stretched, vertically stretched by a factor of 2. So instead of going over 1 and up 1, we're going to go over 1 and up 2. Over 1 and up 2. Okay. And then instead of going over 4 and up 2, we're going to go over 4 and up 4. So 1, 2, 3, 4, 1, 2, 3, 4. So our stretched function will look something like this. All right, so our domain is negative 2 to infinity, and our range is positive 2 to infinity. Okay. All right, problem D. G of x equals 2 times the cube root of x minus 2 plus 1. So this function has been shifted to the right 2 and up 1. So our new turning point would be 2, 1. Okay. Oh, and let me write my critical points here that I'm going to use. 0, 0, 1, 1, and 8, 2. But what I want you to notice is this function has also been vertically stretched by a factor of 2. So from this point right here, instead of going over 1 and up 1, we're going to go over 1 and up 2 because we've been vertically stretched by a factor of 2. So over 1, up 2. And then for the third critical point, 8, 2, instead of going over 8 and up 2, we'll go over 8 and up 4. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So our right branch is going to look like this. And then we're going to have down 1, left 1, down 2. And left 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Something like this. So we have a vertical stretch by a factor of 2. Again, our domain is negative infinity to positive infinity, or all real numbers. All right, example 2. Write the function described. We have a cube root function. So that would be, let's see, f of x equals cube root of x, which has been shifted right 3 and down 2. So x minus 3 would be right 3, and down 2 would be minus 2. Problem B, a square root function, which has been vertically stretched by a factor of 2 and shifted to the left 5. So f of x equals, we have our square root of x, and we want to vertically stretch it. That means the 2 goes on in front of the square root, and it's been shifted left 5, so plus 5. All right, pause the video and try problems C and D on your own. All right, welcome back. Let's see how you did on problem C. We have a square root function. It's been reflected across the x-axis, so we need a negative here. Shifted up 1 and left 2. So for left 2, we need a plus 2 under our square root, and shifted up 1, we need a plus 1. So check your answer with mine. Fix anything that you got wrong. All right, on problem D, we have a cube root function. So f of x is equal to cube root of x. It's been vertically compressed by a factor of 1/2. Since it's vertically compressed, that would go in front of our cube root, and shifted down 4. So out to the side, we want a -4. All right, again, check your answer with mine. Fix anything that you got wrong. All right, example 3. The functions f and g are graphed on the same grid. State the function family the functions belong to. Describe the transformations on f that result in g using a verbal description and in terms of f of x using function notation. Use your understanding of transformations to write an equation representing g. All right, so let's start with f of x. The function family for f of x, since it extends in one direction only, is f of x equals square root of x. Now, we're going to describe verbally how f of x was transformed to create g of x. So if our original endpoint was at 0, 0, and our new endpoint is at -2, +2, that means our function shifted left 2 and up 2. The next thing we want to do is check for a stretch or compression. So in the parent function, notice we're starting at 0, 0, and then we're going up 1 over 1. In our new function, if this is our new 0, 0, notice that it is going up 2 and over 1. So it has a vertical stretch by a factor of BFO 2. A vertical stretch by a factor of 2. So for our function notation, we could say y is equal to 2 times f of x plus 2. That gets us left 2, and then up 2. That's a lot of 2's. All right, so for our equation, we would say f of x equals 2 times the square root of x plus 2 plus 2. So our domain of our g of x function would be -2 to infinity, and our range would be +2 to infinity. Now let's try one with a cube root function. Look at problem B. So our parent function is right here. It has a turning point at 0, 0, and notice it goes up 1 over 1 for its first point. Okay, now the function family here is f of x equals cube root of x, because it has one branch going off to the right and one branch going off to the left. So our verbal description here, let's see, our original turning point was at 0, 0. Our new point is 0, -3, 1, 2, 3. So I know it went down 3. Now let's see if there was a stretch or a compression. So if I go up 1 over 1, yes, there's a point there. So there's been no stretch, no compression here. All right. All right, so for our function notation, y is equal to f of x minus 3. And so our equation would be f of x is equal to cube root of x, and then out to the side, minus 3. So our domain, remember on cube root functions, is -infinity to +infinity, and our range is also -infinity to +infinity. All right, problem C. We have another cube root function. Again, here's our original. Its turning point is 0, 0, and it goes up 1 over 1. For our new function, it also has a turning point at 0, 0, but it goes up 3 over 1. So it's going to have a vertical stretch by a factor of 3. All right, so our function family would be f of x equals cube root of x. Verbal description. It did not move left. It did not move right. The only thing that happened is a vertical stretch by a factor of 3. So our function notation would simply be y equals 3 times f of x. Now our equation would be y equals 3 times the cube root of x. Domain, negative infinity to positive infinity. Same with the range, negative infinity to positive infinity. All right, pause the video and try problem D on your own. All right, welcome back. Let's see. Hopefully you said that the function family was going to be square root of x. Now, several things are happening to this graph here. We have moved to the right 2. Just abbreviate that. We have moved 1, 2, 3, down 3. And we have reflected across the x-axis. So reflect across x-axis. So our function notation would be y equals negative f of x minus 2 because we went to the right 2, and then minus 3 because we went down 3. Now the equation for this will be f of x equals negative square root of x minus 2 minus 3. So our domain would be positive 2 to infinity. But be careful on the range because this branch is opening down. That means our smallest y value is negative infinity, and our largest y value is negative 3. And that concludes today's lesson, graphing and writing radical functions.